Hi everyone. Now to demonstrate the squeeze theorem, or the sandwich theorem, first let's draw a couple lines, shall we? So I now have these three beautiful lines that have magically appeared. Let's call the top function h of x. Let's call the middle function f of x. And let's call the bottom function g of x. Now, as you can see, there's this point where h of x and g of x and apparently f of x all seem to converge. Well, let's call the x coordinate of that line c. So what the squeeze theorem says is that if g of x is always less than or equal to f of x, that seems to be the case, which is always less than or equal to h of x, and the limit as g approaches c is equal to some number L, and the limit as h of x approaches c is also equal to L, then the limit as f approaches c is equal to L. Now if you think about it, that makes perfect sense, because we know h of x has to always be greater than or equal to f of x, and g of x has to always be less than or equal to f of x. So if they both approach the same number, well, what can x be? Or what can f of x be? F of x has to approach the same number, because it can't be greater than h of x, and it can't be less than g of x. So that's basically the squeeze theorem. The only other thing you really have to remember are these three trigonometric formulas. The limit as x approaches 0 of sine of x over x is 1. The limit as, I hope you can read this actually, but the limit as x approaches 0 of tangent of x over x is equal to 1. And the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. Now, I know there's something else that's covered in the lesson, and if this doesn't interest you, you can stop now. But there is a proof that sine of x is equal to sine of x over x as x approaches 0 is equal to 1. Honestly speaking, this isn't that important to the class. However, if it does interest you, there is this wonderful proof by Kwon Academy, if not somewhat lengthy, and I would recommend that you see that if you're interested. Thank you, have a nice day.